Hello friends, welcome to True Abundant Academy. In this particular lecture, we will discuss about the rectilinear motion. So let's begin. So when a particle moves along a straight line, its motion is said to be a rectilinear motion. So basically, what is the concept of the rectilinear motion is that if the motion is on a straight line, then we call that motion as a rectilinear motion. So let us consider this as a straight line, and let us take a particle P, which is at a distance of x from the origin. So let us take the fixed point as origin. So we have the position vector of this point P is OP vector. Let us take this as a R vector. Okay. So we have R vector. We have the position vector as we have position vector of point P. P is equal to OP vector is equal to R vector is equal to x into I cap. I cap is the unit vector along the positive x direction. So we have OP vector is equal to x into I cap, and we have I cap as constant. Okay, so we can take out of the derivative. Okay, so we have the velocity at point P is equal to V. So V vector is equal to d upon dt of OP vector is equal to d upon dt of x into I cap. This is equal to dx upon dt into I cap. Okay, so this velocity is positive in the direction of x increasing, and we have velocity as negative in the direction of x decreasing. How we can find the acceleration? Acceleration at point P is equal to d of dt of v vector. So we have dv upon dt. So acceleration is given as acceleration is equal to d upon dt of dx upon dt of I cap. So we have d2x upon dt square into I cap. Okay. So we have acceleration as d2x upon dt square. It is positive if the is force is positive in the force is acting in the direction of x increasing. So if the force is acting in the direction of x increasing, then acceleration is positive. So the acceleration is positive if the force is acting in the direction of x increasing, and it is negative if force is acting in direction of x decreasing. Okay, so here we consider force. Here we consider the direction of force because acceleration is due to force as per Newton law of motion. So we have F is equal to m into a. So the direction of the force is as per the direction of the force. Okay, let us move further. So this we have already discussed. You can read this in this slide. Okay, so we have the velocity as dx upon dt of I cap. Velocity is equal to dx upon dt into I cap. This we have already discussed. And v is positive in the direction of x increasing and v is negative in the direction of x decreasing. This we have already discussed. Okay. In the remarks portion, we have in case of a rectilinear motion, the acceleration of a particle is taken as d2x upon dt square along the line itself and is taken as positive or negative sign accordingly. It acts in the direction of x increasing or x decreasing. Okay, this we have already discussed. Since the acceleration is produced by the force, therefore, while considering the sign of d2x upon dt square, we must notice the direction of acting force and not the direction in which the particle is moving. This we have already discussed. For example, if the direction of acting force is that of the x increasing, then d2x upon dt square must be taken as positive sign. Okay, whether the particle is moving in the direction of x increasing or in the direction of x decreasing. And we can write the acceleration in various forms, that is dx upon dv upon dt. Secondly, we have v dv upon dx. Thirdly, we have d2s upon dt square. or d2x upon dt square. Okay. So we have d2x upon dt square, dv upon dt, and v dv upon dx are the three expressions of the representing the acceleration, and one of them may be used to suit the convenience in working out problem. So let us discuss questions on this topic. So let's start. So let us discuss question number 1. If at any time t the displacement x of a particle moving away from the origin is given by, so let us consider O as origin. Okay, and the distance of that point from the origin is x. Okay, the distance of this particle at any time t. So p at t is equal to t. The position is at a distance of x from the origin. So at this point p, we have to find the velocity and acceleration. How we can find that? So we have the displacement at time t is given as x is equal to a sin t plus b cos t. So the velocity is equal to dx upon dt. So let us differentiate this with respect to time. So we have a cos t minus b sine of t. So this is our velocity. Now acceleration is equal to first derivative of velocity. So we have this as d upon dt of this. Let us differentiate equation 1 with respect to 2. So we have this as minus a sine t minus b cos t. So this is equal to minus of a sine t plus b cos t. Okay, and this is equal to x. So this is x. So this is equal to minus x. So acceleration is equal to minus x. So we have the velocity as a cos t minus b sin t, and acceleration is equal to minus a sin t plus b cos t is equal to minus x. Okay, so this is our velocity and acceleration of the particle at time t is equal to t. Okay. So what is given in question number 2? A point moves in a straight line so that its distance s from a fixed point. So we have a fixed point. Okay, so let us consider this as origin. So we have a distance s from the fixed point. This is our position of the particle p. And what is given in the question? So that is distance s from the fixed point at any time t is proportional to t to the power n. S is proportional to t to the power n. S is equal to k t to the power. This means let us take this constant k as constant. So this is constant times of t to the power n. S is equal to k t to the power n. If v be the velocity and f the acceleration at any time t, show that v square is equal to nfs upon n minus 1. Okay, this we have to show. So we have s is proportional to t to the power n. This means s is equal to k times of t to the power n, where k is equal to constant. Okay. So how we can find the velocity? The velocity is equal to ds upon dt. So let us differentiate this. K into n t to the power n minus 1. This is our velocity. And we have the acceleration. Acceleration is equal to f at this at the position of this particle p at time t. So we have f is the acceleration here. So we have v is the velocity and f is the acceleration at this point p. So we have acceleration f is equal to d2s upon dt square. So this is equal to differentiate equation 1 with respect to time. So we have k into n minus 1 t n minus 2. This is our acceleration. Okay, so now what we have to find is that we have to show this v square is equal to nfs upon n minus 1. So let us find v square. So v square is equal to let us square this. So we have this as k square n square t to the power 2n minus 2. Okay, so this let us rearrange this. So let us take first term as n. Okay, so what we are left with, and we have f as this one. Okay, and we have k square. So let us write down this like this. So we have n square is there, no? So we can write this as n times of nfs. So we have f as this. So let us write down f here. Kn t to the power of n minus 2. and where we have k square. So let us multiply with k for making it as k square. So we have k here and k here. This is k square. We have n and n here. We have n square. Now we are left with t2n minus 2. Okay, so we have here n minus 2. Okay, so t to the power n we will multiply. So now tn minus 2 and tn. This is 2n minus 2. So now we have this term as n minus 1. So let us multiply in numerator with n minus 1 and divide by n minus 1. Let us rearrange this. So we have n into this is k times n. Let us put n minus 1 here. So n into n minus 1 into t to the power n minus 2. Okay, this is f. Now we are left with k times this one. K times t to the power n upon n minus 1. Okay, so let us compare this. So we have this particular expression as f. This is n and this is s. So this is equal to nfs upon n minus 1. This is v square. Okay. Hence, what we have to show is v square is equal to nfs upon n minus 1. This is the required solution. So let us discuss question number 3. So what is given in question number 3? The particle moves along a straight line such that its displacement x from a fixed point on a line at time t is given by x is equal to t cube minus 9t square plus 24t plus 6. Is what is given in first part, the instant when the acceleration becomes 0. So we have velocity as dx upon dt. This is equal to 3t square minus 18t plus 24. Now acceleration is equal to dv upon dt. So this is equal to 9t minus 18. Okay. So what is asked in the question? Instant when the acceleration becomes 0. So let us put this to 0. So we have t is equal to 3 seconds. So at 3 seconds, at t is equal to 3 seconds, acceleration becomes 0. Okay. Now the position of the particle at that instant. So at t is equal to, we have to find the x at t is equal to 3. So this is equal to 3 cube minus 9 into 3 square plus 24 into 3 plus 6. This is equal to 27 minus the 981 plus 24 into 3, 72 plus 6. So this is 78 plus 27. That's 15 का 1, 7, 8, 9, 10. 105 minus 81. This is 4 and this is 24. This is 24 units. Okay, so the position at t is equal to 3 is 24 units. Let us, in third part, what is asked? The velocity of the particle. The velocity of the particle at t is equal to 3. So we have this velocity as 3t square. The velocity at t is equal to 3 is equal to, let us put t is equal to 3. So 3 into 3 square minus 18 into 3 plus 24. This is equal to 27 minus 54 plus 24. This is 27 plus 24. 51 and minus. This is 51 minus 54. This is equal to minus 3 units. So the velocity at t is equal to 3 is minus 3 units. Okay. So let us discuss question number 4. How we can solve this? The particle moves along a straight line and its distance from a fixed point on the line is given by x is equal to a cos mu t plus epsilon, so that its acceleration varies as the distance from the origin and is directed towards the origin. Okay, so how we can solve this? Distance from the fixed point. Okay, so we have this as, let us consider this as fixed point and let us take this as origin. So we have the distance of this point from the origin is as a x, and this x value is given by this particular expression. So now let us find the velocity. Velocity is equal to dx upon dt is equal to minus a mu sine mu t plus epsilon, and we have acceleration is equal to dv upon dt. So let us differentiate this once more. So we have this as minus a mu square cos of mu t plus epsilon, and we have x as this particular expression. This is minus mu square into x. This is acceleration. The acceleration is proportional to minus x. Okay. So hence the acceleration varies as distance from origin, because x is the distance of this particle at time t from origin, varies as distance from the origin, and negative sign indicates that the acceleration is directed towards origin. Okay, now let us discuss question number 5. So a particle moves along a straight line such that its distance x from a fixed point on it, and velocity v are related as. So we have v square is equal to mu a square minus x square. Prove that the acceleration varies as distance of the particle from origin. Okay, so we have, let us differentiate equation 1 with respect to x. So we have 2v into dv upon dx is equal to mu of minus 2x. So we have v dv upon dx is equal to minus mu x. So v dv upon dx is equal to mu into minus x. This is acceleration. So we have studied that forms of acceleration. Okay, there are various forms of the acceleration. First is dv upon dt, and dv upon dt we can write as dv upon dx into dx upon dt. So dx upon dt is v. So this is v dv upon dx. And third, it is d2s upon dt square. So these are the three forms of acceleration. So we have used the second form, v dv upon dx. So we have the acceleration is proportional to minus x. So this means acceleration varies as distance of this particle from origin. So we have considered the distance of this particle p from the origin as x. Okay, so the acceleration is proportional to minus of OP. OP is the distance of this particle from origin. So we can say that acceleration varies as the distance of the particle from origin and is directed towards origin, because of the distance varies as the distance of particle from origin. And we can write here is that negative sign indicates that acceleration is directed towards origin. Okay, let us discuss question number 6. What is given in question number 6? The velocity of a particle moving along a straight line when at a distance x from origin, center of force varies as this particular expression. So we have the velocity of a particle moving along a straight line. So we have distance x from the origin. The position of the particle is at a distance of x from the origin. So this is the position of the particle. The velocity of the particle at this particular instant is given as varies as. Okay, so v is proportional to root under a square minus x square upon x square. So we have velocity is equal to k times of a square minus x square upon x square. So let us square this. So we have v square is equal to k square a square minus x square upon x square. So let us differentiate with respect to x. So 2v into dv upon dx is equal to k square into x4. Okay, so let us differentiate. So we have x4. We have x square into differentiation of a square minus x square. This is minus 2x. Minus of a square minus, a square minus x square into x square का differentiation 2x. So we have this as k square upon x4 into minus 2x cube minus 2xa square plus 2x cube upon x4. This gets cancelled. Sorry, this is x4 we have already written here, no? So we have k square upon x4 into minus 2xa square. This is equal to minus 2k square a square upon x cube. This is 2v dv upon dx. So from here we have v dv upon dx is equal to minus k square a square upon x cube. So we have v dv upon dx is proportional to minus of 1 upon x cube. Okay, so this is the law of acceleration. Okay, so the acceleration varies inversely as cube root as sorry varies inversely as um, cube of distance from origin. Okay, so distance from the origin is x. So acceleration varies as cube of distance from the origin. Okay, let us discuss question number 7. How we can solve this? A law of motion in a straight line being given by s is equal to half v into t. So we can write this as proof that the acceleration is constant. So we can write v is equal to ds upon dt. So we have s is equal to half into ds upon dt into t. Okay, so let us differentiate this once more for getting the velocity. So we have ds upon dt is equal to half ds upon dt into differentiation of t is 1. So we have t into d2s upon dt squared. So let us put 2 here. So 2 ds upon dt minus is equal to ds upon dt plus t times of d2s upon dt squared. So we have ds upon dt is equal to t times of d2s upon dt square. Let us differentiate this once more. d2s upon dt square is equal to t times of d cube s upon dt cube plus d2s upon dt square. This gets cancelled. So we have this as 0 is equal to t times of d cube s upon dt cube. So from here d cube s upon dt cube is equal to 0. This means d upon dt of d2s upon dt square is equal to 0. So differentiation of something is 0. This means d2s upon dt square is equal to constant. So what is d2s upon dt square is nothing but acceleration. So acceleration is equal to constant. This we have to show in the question. Prove that the acceleration is constant. So hence acceleration is constant. Okay. So let us discuss question number 8. A point moves in a straight line so that its distance from a fixed point in that line is a square root of the quadratic function of the time. Okay. So let us consider the distance of that point from origin. So let us consider this as point P. So we have the distance from a fixed point is the square root of the quadratic function of the time. So quadratic function of time is, let us consider this as at square plus 2bt plus c. So square root of this is our distance. So we have x is equal to at square plus 2bt plus c. So we have, let us square this, squaring. We have x square is equal to at square plus 2bt plus c. Okay. So let us differentiate this with respect to time. So differentiating with respect to time. So 2x into dx upon dt is equal to 2at plus bt, sorry 2b, 2at plus 2b. So we have x dx upon dt is equal to at plus b. Okay. This is let us take this. Let us write down this in a manner. Let us take this as equation 1 and this as equation 2. So we have dx upon dt is equal to at plus b upon x. Okay. So now let us further differentiate this. So we have d2x upon dt square. So on differentiating with respect to time, we have d2x upon dt square is equal to x square into at plus b, sorry, We have to differentiate this now. So we have x square into x into a minus at plus b into differentiation of x, so dx upon dt. Okay, so we have and let us multiply in numerator and denominator by x. Okay, so we have this as a into x square, a into x is here and we multiply with x. So this is x square minus at plus b into x into dx upon dt upon x cube. This is equal to d2x upon dt square is equal to. Okay, so we have d2x upon dt square is equal to x dx upon dt. X dx upon dt is at plus b. So we have a times of x square we are having as this one. A times of, so let us put x square here. So this is equal to at square plus 2bt plus c minus at plus b into x dx upon dt is at plus b x cube. Okay, let us further simplify this. So we have d2x upon dt square is equal to a square t square plus 2abt plus ac minus a square t square plus 2abt plus b square, okay, upon x cube. This is equal to ac minus b square upon x cube. This is d2x upon dt square is equal to. Okay, so this is our expression for the acceleration. Prove that the acceleration varies inversely as a cube of distance from the fixed point. So we have the distance from the fixed point as x. This is the position of the particle and this is O. Let us name x as OP. So this is equal to AC minus B square upon OP. Therefore, d2x upon dt, OP ka cube na, is proportional to 1 upon OP cube. That is, acceleration is proportional to 1 upon distance of point from fixed point ka cube. Okay, let us discuss question number 9. How we can solve this? If a point moves in a straight line in such a manner that its retardation is proportional to the speed. So retardation is given by minus dv upon dt is proportional to its speed. So we have v. So we have minus dv upon dt is equal to k into v. So we can write dv upon dt as v dv upon dx. Okay, so this is minus v dv upon dx is equal to k times of v. So this we can cancel. So we have dx is equal to minus 1 upon k of dv. Okay. So let us integrate this. This is equal to x is equal to minus v upon k plus constant of integration. Let initially at x is equal to 0, the initial velocity is u. So we have 0 is equal to minus u upon k plus a. So therefore a is equal to u upon k. So let us put a is equal to u upon k in this particular expression. So we have x is equal to minus v upon k plus u upon k. This is u minus v upon k. So we have k into x is equal to u minus v. So this is the, what is this expression? This expression shows that this x is the space. So at a time t, we have the position as x. This is the position of the particle at time t is equal to t. This is the position of particle and this is origin. So x is equal to a space described by the particle at time t. This is the case. X is the space described by particle at time t, and u minus v is speed destroyed in that time. U is the initial velocity and v is the final velocity. So u minus v is the space destroyed. Sorry, speed destroyed in time t. Okay. So this we have to show that the space described by the particle in time t is proportional to the speed destroyed in that time. Okay. चलो उसके बाद question number 10. Okay. So prove that if a point moves with a velocity varying as any power not less than unity, the power n is not less than unity, okay, of its distance from a fixed point which is approaching, it will never reach that point. Okay, so what is given in the question is that if a point moves with a velocity v varying as v is proportional to any power of its distance from a fixed point. So let us consider the distance from the fixed point as x, okay, and velocity is proportional to x to the power n, where n is not less than 1. This means n is greater than equal to 1. Okay, so v is proportional to k to the power, x to the power n. So we can write as v is equal to kx to the power n. So we have two cases here in this, from this. N is greater than 1. The first case is n is equal to 1 and case 2 is n greater than 1. Okay, so this point is approaching the fixed point with a velocity v which is proportional to x to the power n. So we have to show that it will this particle will never reach this fixed point. Particle will never reach, मतलब और इस fixed point पे पहुंचेगा ही नहीं कभी. Okay, that we have to show. Particle will never reach fixed point. Okay, so we can write this as particle moves with a velocity varying with any power of a distance from the fixed point. It will never reach the fixed point. Okay, so we have v as dx upon dt is equal to kx to the power n. So let us take case 1. Case 1 we have n is equal to 1. So the equation 1 becomes dx upon dt is equal to k. Sorry, we have the velocity is equal to minus dx upon dt because this particle is approaching the fixed point. Okay, so we have the velocity is in the direction of x decreasing. So we have this is minus dx upon dt. So minus dx upon dt is minus k into n is equal to 1 to x. So we have this as dx upon dt is equal to minus kx. So we have dx upon x is equal to minus kt k into dt. So we have dt is equal to minus 1 upon k into dx upon x. Let us integrate this. So we have t is equal to minus 1 upon k log x plus a. So at x is equal to 0, the particle particle reaches origin, that is fixed point. So let us put x is equal to 0 in this equation. So t is equal to minus 1 by k log of 0 plus a. This is equal to log of 0 is infinity. This means it take infinite time to reach fixed point. This means therefore the particle will never reach the fixed point because the t is coming as infinity. How it can approach the fixed point. Okay, so let us take case 2. Case 2 we have n is greater than equal to 1. Case 2. In case 2, we have n is greater than 1. Okay, so minus dx upon dt is equal to kx to the power n. So we have, uh, we can write this as dt is equal to minus 1 by k x to the power minus n into dx. Okay, so let us integrate this. So we have t is equal to minus 1 by k x to the power minus n plus 1 by minus n plus 1 plus constant of integration. So we have t is equal to minus 1 upon k x to the power 1 minus n upon 1 minus n plus b. So t is equal to 1 upon k 1 upon n minus 1 into x to the power n minus 1. Okay, plus b. So at x is equal to 0, we have, so let us put x is equal to 0. So this is 0 is in the denominator and n is greater than 1. So n minus 1 is positive. N minus 1 is positive. Okay, positive quantity. So we have 1 upon 0 is infinity. So t is equal to infinity. So this means on putting x is equal to 0, it will take infinite time to reach the fixed point. This means the particle will never reach that fixed point. This means particle will never reach the fixed point. समझ में आ रहा है? So we have taken two cases. N is equal to 1 and n is greater than 1. In both the cases, t is coming as infinity. T is equal to infinity. In second case also, t is equal to infinity. So it is taking infinite time to reach the fixed point. This means, this implies that this particle will never reach the fixed point. So let us discuss question number 11. How we can solve this? The velocity of a particle moving along a straight line is given by the relation v square is equal to ax square plus 2bx plus c. So we have to find the acceleration. So we will take the expression as v dv upon dx as acceleration. Prove that the acceleration varies as a distance from the fixed point in the line. So 2v into dv upon dx is equal to 2ax plus 2b. This is equal to 2 times of ax plus b. So 2 gets cancelled. So we have v dv upon dx is equal to a times of x plus b upon a. Okay, so this is acceleration. Okay, so these have acceleration as O. Let us take the fixed point as x is equal to minus b by a. Let us take x is equal to minus b by a as the fixed point. Okay, and this is our origin. And this point P is at a distance of x from the origin. Okay, and we have taken the fixed point as x is equal to minus b by a. So let us name this as O dash. So this whole distance is O dash p. O dash p is equal to, this is x and this is b by a. So this whole distance is x plus b by a. So we have acceleration is equal to a times of O dash p. This means acceleration is proportional to O dash p. This means acceleration is proportional to distance of point p from fixed point. The fixed point we have considered as x equal to minus b by a. Okay. So let us discuss question number 12. So what is given in question number 12? If t is regarded as a function of v, this means t is equal to function of v. Prove that the rate of decrease of acceleration is given by. The rate of decrease of acceleration is, we have f is equal to acceleration. So rate of, we have the acceleration. Matlab rate of decrease of acceleration. Decrease of acceleration is equal to minus df upon dt. Okay. So we have f is equal to dv upon dt, and since t is regarded as a function of velocity, so we have minus df upon dt is equal to d upon dt of minus of d upon dt of dv upon dt. This we can write as minus d upon dt of dt upon dv minus 1. Okay, so this we can write as minus d upon dv of dt upon dv minus 1 into dv upon dt. Okay, so this we can write as um, first we have to differentiate dt upon dv minus 1 with respect to dt upon dv. This is equal to minus plus, so dt upon dv minus 2 into d2t upon dv square into this is dv upon dt. Okay, this is minus d upon dt. So we have minus df upon dt is equal to, this we can write as um, dv upon dt ka whole square. This we can write as dv upon dt ka whole square into d2t upon dv square into dv upon dt. So this is equal to dv upon dt ka whole square into d2t upon dv square minus df upon dt. So this is equal to rate of decrease of acceleration. Rate of decrease of acceleration is equal to dv upon dt is acceleration. This is f square into, sorry, f cube na, dv upon dt ka square into dv upon dt. This is f cube. This will be dv upon dt ka cube. This is f cube into d2t upon dv square. Okay. Okay. So this is the rate of decrease of acceleration, which is given by f cube into d2t upon dv square. This is being asked in the question. F cube into d2t upon dv square. Okay, so we have discussed total questions, 12 questions on this topic. Okay, thank you.